see if how that affected you. But again, I can't complain. You guys, you're sitting here at what did I say? 84 point. Let's try and get that up over 85% before we go into Christmas break. Make that our goal. Sound good to everybody?
We have a quiz at the end of this week.
Okay. I doubt it. I seriously doubt it. I think today we'll get through 6.2. We might start 6.3 tomorrow or Thursday. If we do a quiz at the end of the week, it would be maybe kind of a group quiz just going into the break, okay? So we'll see how it plays out here. I'm not going to rush to get to a quiz because that's what we have to do. I'm going to teach and teach you the right way, and wherever we get is wherever we get when it's time for break. Make sense?
Mm-hmm.
Tristan, you need some notes, don't you, kiddo?
Better than what Miss Wick's doing.
Well,
What?
I don't know what you're doing, Josh.
Doesn't matter. I'm doing it.
Yeah, it's
Yeah, they're all easy.
What are you doing,
Guys, Josh, if mine can frisbee can pass, anybody can pass.
Yeah, all we have to do is test and math. That was literally right 4 sentences.
I barely passed that class.
We only have to write 4 sentences. We're gonna complain about that.
Don't worry, I got an A in that class and I didn't do that assignment.
I get like a system. I got to even do a poster. I don't want Josh to stop because he's a baby and he can't write 4 sentences.
And you guys win.
Jeez, Josh, they're all over you.
Computer games during math
I feel
class.
angry with I hear people complaining because
That's
it's
not
really
what it was on
frustrating.
before.
Those are fighting words.
All right, y'all ready to roll here? Here we go, okay? Guys, 6.2, title is perpendicular and angle bisectors. Michael, you want to read my essential question for us today? What are we trying to solve?
What conjectures can you make about a point on the perpendicular bisector of a segment and a point on the bisector of an angle?
Okay, first of all, this word bisector means cut stuff in what? Okay, this word bisector means to cut
In half.
in two equal what?
Part.
Yep. So, just as an example, if I was going to bisect $50, I would bisect into two equal payments of $25. Okay, so you get that, two equal parts, okay? We'll look at what some of this terminology means, and we'll make some diagrams of this here, but in order to be able to answer that question up there that Michael read, we're going to have to be able to use perpendicular bisectors to find measures, okay? Perpendicular means what angle is formed? 90 degrees, yep. Use angle bisectors to find measure and distance relationships. And then we're going to write some equations for perpendicular bisectors. So I got to be honest with you, not so much about proof today as much as it is understanding what these rules about bisectors mean, okay? So if I told you we kind of get a day off of proofs, how would you feel about that?
Good.
You'd be happy about that. Okay, vocab. What do we need to understand vocab-wise? Volunteer to read this one, equidistant for me.
Got you.
Okay, Michael.
A point is equidistant from two figures when the point is the same direction from each figure.
Same distance, right? Okay, a point is equidistant from two figures when. So let's just say here. I'm going to say A is here. Figure B is right here. I'm going to say figure C is maybe up here. I would say C is equidistant from A and B if the distance from C to A and C to B are the what? So maybe I say this is 12. What would the distance from C to B have to be? Okay, so this point C, I would say C is, I'm going to abbreviate, equidistant, EQD, from what 2 points? Okay, so I would say C is equidistant from A and B. That's hard to read up there, but do you get that? Okay, so equidistant just means it's a point is equidistant from two figures if the point is the same distance from each figure. Okay? Now we're going to talk about some concepts last year. It says how far is a point from a line or how far is a point from a line segment. We're going to talk about the importance of forming perpendiculars with that finish line that we're getting to, but we'll talk about that in a little bit. Okay, perpendicular bisector. Anybody want to read that one?
I got you.
Michael!
A perpendicular bisector is a special kind of segment, ray, or line. One intersects a given segment at a 90-degree angle, and two passes through the given segment midpoint.
Okay, so let's just assume I have something like this. Let's say we have a line segment. So a line segment is going to have a starting point and what else, kids?
And
And it has an ending point. So maybe our starting point on the left is J. Maybe the point over here is P. Okay? What's my starting point? J. Ending point is P. Okay? It's going to have a certain distance here. A perpendicular bisector would cut that in what? Well, when I talk about not just bisecting it or cutting it in half, if I say we're going to cut it perpendicularly, the bisector is going to form an angle that is how many degrees? Okay, now this could be a ray, it could be a line, it could be a line segment. Let's just put a line in there. How's that sound, kids? We'll use a line as my bisector. I could use a ray, I could use a line segment, but does this look about the middle right here, guys? Is that a perpendicular bisector? Is that a perpendicular? Tell me about where you want me to be and cut that.
About right there, that's about right.
About right there?
Well, I think one back.
To the right one on the bottom or top?
I mean, we understand what it's supposed to look like.
Either way.
It has to be perpendicular.
As long as you put a little box on there, you know, to show that it's perpendicular and not even.
I like what you're saying there, Jacob. We'll talk about that.
Yeah.
Right there.
Better?
That's the one.
Is that the one?
That's the
Okay, now can I assume that that's a perpendicular bisector, first of all?
cannot.
And
No.
Measure it.
These two lines are going to form at a point. Most of the times when I talk about points being in the middle, they usually call this M, stand for midpoint. Guys, is that a perpendicular bisector now?
Yes.
It is now.
Be very careful. How do I know that JM and MP are equal?
There's that box there.
it's got a box.
Well, so it means 90 degrees, but how do I know what this
You gotta
sig?
have the dash.
Yeah, I want to put a little tick mark here and a little tick mark there. Here, a tick mark there, a tick mark everywhere, a tick mark. Means JM and MP are equal. Okay, if have I cut that segment J to P in half now into two equal segments?
Yeah.
I have, haven't I? Okay. All right, so hopefully everybody's getting this down. Pay attention to it.
I got
Hopefully everybody's got that. Okay. All right, next one, angle bisector. An angle bisector is any segment, ray, or line that cuts an angle into what? Two equal angles. So suppose I have this, kids. Suppose I have an angle that looks like this. Okay. Here's my angle right there. Whoops, come on. Why didn't that work? I have a hard time with this sometimes.
That's my light.
Okay, here's my angle right here. Okay, that's the angle. Here would be an angle bisector. An angle bisector is going to run out here somewhere. It's going to cut these two angles into two equal angles. And what you'll see for an angle bisector is two arc marks. You'll have an arc mark here, arc mark there. That indicates that those two angles are what? Equal. Okay, so if you have two equal angles inside of a bigger angle, that means that this is a bisector for that. And we'll get some terminology to this, but that's what an angle bisector means, okay? All right, theorems to know today, kids. Theorems to know. These are going to be applied later on in the chapter, but things to know. We're going to look at this today. First one's called the perpendicular bisector theorem. It says in a plane. What's a plane, kids, again? Flat surface. Planes, Trains, and Automobiles, a wonderful movie as well. Okay, it says in a plane, if a point lies on the perpendicular what? Bisector of a what? Then it is
Equidistant from the endpoints of the segment.
equidistant from the endpoints of the segment. Let's just talk about what this means. Let's draw a picture for this, okay? If I have a line segment that looks like this, kids. I have a line segment that looks like this. Okay, it has a starting point. Maybe I call this A over here on the left, and I call this B over here on the right. What kind of bisector do I have, kids? It says I have a perpendicular what? Does that look about right to you guys? Okay, perpendicular bisector. I'm going to call this point what for midpoint? Okay, 90 degrees. Okay, here's what this theorem is saying. MB would be equal to AM. Is that right, kids? Okay, what this is saying is this. In a plane, if a point lies on the what, kids? So let's just pick a point. Maybe we pick this point and we'll call it P. It's on my, we all agree that this is a perpendicular bisector. Here's my perpendicular. Cuts this segment AB into two equal parts. If I pick this point P up here, then what this means then is the following, kids. It means that P is equidistant from what, kids? So if I draw this in here like so, from P to A,
I remember.
that distance from P to A is the same as that distance from P to B, okay? So I've already used one tick mark here, so I'm going to double tick mark this. This implies that PB would be the same as what? PB, a point P on that perpendicular bisector is equidistant to the end point. So PB would equal what? PA. Okay? Then the converse of that is true. It says the following. In a plane, if a point is what, kids? Equidistant from the endpoints of a segment, then it lies on the what?
Equidistant.
So let's just say this. Suppose I have a line out here that looks like so. A line segment that looks like so. And I'm going to tell you there's a point up here. Maybe this point up here is P again. And if I tell you the distance from P to this endpoint is the same as the distance from P to this endpoint, then it says, well, P must lie on the what then, kids? P is going to lie on the what? Okay, this line that goes through here, this line that would go through here would be the perpendicular bisector of that, okay? So if that happens, then if you know that those 2 points are equidistant, then this perpendicular down here is going to divide this down here into 2 equal parts. Okay? That's what those theorems say in terms of a visual. All right? Okay, do you have those down? That's my first question.
Yes, sir.
On a perpendicular, if a segment has a perpendicular bisector, any point on that perpendicular bisector is equidistant to the endpoints of the segments. So let's put this into action. Okay, this is kind of hard to see, so let me blow this up. But we're going to use the perpendicular bisector theorems. I think you can read it better in your notes. It's a little blurry up here, but kids, it says find what? So in part A, we're trying to find C to D. Well, guys, look at it. They tell me that the distance, this here, is a perpendicular, and it's a bisector, isn't it, kids? Because A to B is the same as B to what? So isn't BD my bisector for AC right here? So if I'm looking for the distance from C to D, which is right here, what's that distance going to be?
27.
How do you know it's 27?
Yeah, you need a label.
Is that meters?
Okay? Units. 27 units. Okay?
Put the label on that.
Enough of the lid. PR. I'm not gonna beat on you too much, but if this is 5 down here, and this is a perpendicular, we know this would be a perpendicular bisector because S is equidistant from S to P is how much?
13.
And S to R is how much? So that means that PQ must be equal to what? Yep, this is a perpendicular bisector. This is kind of the converse. They're saying these points are equidistant, therefore this is perpendicular. So they want PR here. Well, what's Q to R going to equal, kids? So what's that make PR? PR would equal
10 units.
10 units. Okay? Same thing down here, GH. Ooh. Okay, kids, I have a line here, H. Is this a perpendicular bisector?
Sure.
Okay, the distance from E to F is the same as the distance from what to what? So once I know that, what must be true about this distance and this distance?
That they must be the same.
Okay, so what we're going to do in part C here is we're going to set 2x equal to what, kids?
3x minus 8.
Okay, so what's x going to equal when I solve this? I'm going to subtract 3x from both sides. So I've got negative 1x equal negative 8. You just said x was going to equal how much?
8.
Okay, but does that help us solve from the distance from G to H that they want you to find right here?
Now you gotta put it in the
Because you
equation.
gotta
Yeah,
keep up
so I'm
with
going to take this
X
8 and plug it in right there.
16 minus
So help me out, kids. GH would equal 3 times 8, which is what?
8 is 24.
Minus 8 more. So G to H is how many units here, kids? Okay, quick question. Do you guys get that if I have a triangle where I have a perpendicular, why is this perpendicular? 90-degree angle. Why is this a bisector? Why do we know what's a bisector?
Got the little line.
Little tick marks down here. EF is congruent to FG. That means that this point H is equidistant from the endpoints of GE, which means that the sides HE and HG must be what? Okay. Are we good with that?
It's easy money.
It's pretty simple, isn't it?
Pretty simple.
All right, so I'm going to run into my book here. You guys don't need to do this. I'll pull this up here for you. Leon Bridges.
Coming home.
Let me get the page. What did that say in your notes? 300 and...
45.
Yes, sir.
Is that Taylor Swift?
Oh my gosh.
Oh my gosh, it's Taylor.
What's his face in front?
Can you guys see this diagram okay right here? Okay, there's a triangle up here. It says KMN right here. You guys see the point L up here?
Yeah.
Okay, let's talk about this real quickly. It says up here in this information up here, K to L is there, N is here. It says, is there enough information in this diagram to conclude that the point N lies on a perpendicular bisector here? Now, I'm having a hard time seeing if there's any angle measure up here. I don't see that there's any 90 degrees up here, but I see, kids, that L to K is what? Isn't there a tick mark here? Is there a tick mark right there also? Just because they're equal, though, doesn't mean that this angle is how many degrees. So I don't know if that's 90 degrees. Okay, so let's look at what we're asked to figure out from that diagram right there. In our notes, we're asked to figure out, is there enough information given in the diagram in example 2 to conclude that what? L is on the what? L is on the perpendicular bisector. Well, let's take a look here. First of all, these are equidistant. But do I know if there's a perpendicular right here, kids?
No.
Okay. So I don't know, and it says if L is on... I can say L is definitely on the bisector, isn't it? Because isn't the distance from K to L right here the same as the distance from L to M?
Yes, sir.
It's definitely on the bisector, but we don't know what. Yeah, we don't know if it's 90 degrees. So I think what I would say here is this. This is what I'd probably say. I would say
No.
L is on the bisector. But what, kids?
It doesn't say if it's perpendicular.
There's not a little part.
So is it okay if I write down, but we're not sure it's perpendicular given the diagram? Just not sure given the diagram up there. Okay, so L is there. So is there enough information up there to tell if that's on the perpendicular bisector? No, we know it's on the bisector, we just don't know if it's perpendicular. So the answer to that question is, we don't know. No, there's not enough information. Okay? All right. More theorems to know.
There are a lot of theorems.
It is. Okay, anytime I highlight these theorems, you're always going to want to be able to make sure you come back to them. Okay, what's the first one there, kids?
Angle.
The angle bisector.
Angle bisector theorem states if a point lies on the what?
Bisector.
Then it is equidistant from the two sides of the angle. And this is what I really want to point out here. Let's make an angle down here. Let's talk about what the heck is even going on here. So let's make an angle down here. Okay, maybe I have this angle right here, kids.
Ooh, that's a
How many degrees is it?
62. Okay. Here is my angle bisector right here. Okay? So here's what this is saying. I'm going to draw an angle bisector out here like so. Okay, if this is an angle bisector, what's true about this angle?
Same as other.
It's the same as this angle right down here. So I'll put some arc marks in here to indicate that those two angles are equal. Okay? Now I want you to understand something, kids. What this is saying is this. If I choose a point, let's choose a point P out here. If there's a point P on my bisector. So you guys all agree P is on the bisector. That's my first question.
Yeah.
It says then, if P is a point on that bisector, that point is equidistant from the two sides of the given angle. Okay? Now when I talk about the distance, this is kind of tricky. This means perpendicular distance. So it means that it's talking about the distance from, watch what I do here.
Oh, that's sketchy.
You're sketchy.
Watch what I do here.
Perpendicular from
A
which?
distance could be right here to that. Is that a distance there? Yeah, but is there a perpendicular angle formed to that side? No, so tell me when you see kind of a perpendicular angle up here
So it
about.
has to be perpendicular to the
Yes.
other one, not that one.
So this point from P down to this side has to form what angle down here? 90. That's the distance we're talking about right there. And then it also has to form what angle with this side? Can I just go straight over like that? Is that working?
Yeah.
Tell me when I'm at about 90 degrees. That looks about 90 degrees.
That looks pretty close.
It's pretty close there, isn't it?
Yeah.
Oh, shoot. Does that look like about 90 degrees right there, kids? So what that is saying is this. When there's 90-degree angles, if there's a point P right here on your, it says that this distance and this distance are the same as long as the distance to those lines. It's like running a race. Where are my tracksters at? You run a race to the finish line. Are you crossing at an angle or are you kind of crossing on a perpendicular path?
Well, it depends on which one you.
Well, it depends. Hopefully you're crossing on a perpendicular path because that would be the shortest distance to that finish line, okay, from the point you're at. Got it? Okay. Oops, didn't want to do that. Okay, and then the converse of this is true. The converse says if a point is in the interior of an angle and is equidistant from the two sides, then it lies on the bisector. So they're saying this. If you had an angle that looked like so, they're simply saying, what if you had an angle that looked like this? Angle.
Can you even
And they're saying, what if this point right here, I don't know, if this point is equidistant from that side and this side right here. If this and this are equal, and this is 90 degrees right here, then this point must lie on the what, kids? Yeah, that point would lie on your bisector then. So that bisector would go right through like that, meaning that this angle and this angle would be the same. Okay? So angle bisector theorem and converse to the angle bisector theorem. So let's put those into action here.
Wow.
Anybody need more time writing those diagrams?
A little bit.
All right, talk to me here, kids. In fact, you know what? You guys try part 3 on your own. See what you get for those two measures. Find each measure. Okay, guys, how is D related to side BC and BA?
What?
How is D related to the side BC and BA?
It's
What's the word I want?
bisector.
Well, it's on the bisector, but how do I know it's on the bisector?
Because of theorem.
That point D is equidistant from both sides of the angle, right? And since it's equidistant and this is a 90-degree measure right here, if this is 56 degrees, what's that force this to be right here? Means it's on the angle bisector, so these two angles would be equal. So if I want the measure of angle ABC, A to B to C right here, what are you going to have to do then? What'd you guys get for that? Show of hands, please. How many had 112 degrees for that one? You okay with that? 112 degrees?
Yes, sir.
Okay. Somebody talk me through JM. What am I going to do with JM?
Okay, so you got the 4x and you got
Okay.
the 2x plus 12.
All right.
Well, you're going to find the x value.
Okay.
You got this 4x equals 2x plus 12.
Okay. Why can I set 4x equal to 2x plus 12 here, kids?
Well, because you can move all the x's to one side.
Well, I want a reason here.
Oh.
Part of the reason's right in here that I'm pointing at.
It's on the
The
bisector.
angles are the same.
Yeah, M is on the angle bisector here, and any point on an angle bisector is equidistant from either side. So that makes JM equal to what?
ln.
Okay, so subtract 2x from both sides, and you've got 2x is equal to what, kids? 12, which forces x to be what value? Okay, so if x is 6, how does that help me solve for JM?
Put that in x 6 for the x and 6 times 4 is 24. So I think it's 24.
24 units. I like. How many had 24 for that? Awesome. Okay, I think you guys are onto this. You're doing great. Keep it up. Okay. Example 4. A parachutist lands in a triangular field at point P and then walks to a road. Will you have to walk further to Wells Road or to Turner Road?
Go for
The same.
I think go for wheels.
How do you know it's the same?
Because it's on the
Because
bisector.
it's leaning.
Now again, we have to assume if he's walking to a road, hopefully he walks the shortest distance, right?
Yeah.
Okay, so what angle is he going to form with this road over here? Whoa, shoot, I screwed that up.
90.
We hope it's a 90-degree angle, right? We want this to be a 90-degree angle here, so from here to here, is that looking like about a 90-degree angle to that side? Right about there? And how about here? What angle do I need to form with this side? Does that look about like 90 degrees right there? What's going to be true about these kids? This angle up here is equal to this. This point has to be, this should be the same as this, so
It's a trick question.
it's a trick question here.
I told you.
Will you have to walk further to Wells?
There's
The answer is neither.
there.
They are the same distance, right?
But there's probably a stoplight on Wells Road, so it's probably traffic.
What are the odds that he lands right in there?
Let's say 1 to 100.
Alright,
Well, I could look at that area of the triangle and figure out what the probability would be. I can figure a small area. Okay, how you guys feel about this? Pretty good?
I feel fine.
Okay, last example, and I want to make sure everybody has that down. I'll go when I know everybody has that down. I'm sorry. Any of y'all need more time? Perpendicular bisectors and angle bisectors. Are you okay with the rules and the theorems that come along with it so far?
Yeah. I'm so
You don't
tired.
put this level across there.
Okay, here we go. Last one. Ooh, this is interesting. So write an equation of the what?
Perpendicular bisector, the segments of M points D, 5,
Okay, I'm going to get a visual of this here first of all. Okay, what 2 points are we talking about, kids? So, how do I want to do this? I want to do this. Okay, so let me. Okay, what's the first point, kids? 5, negative 1. What's my next point? Negative 11, 3. Okay, here's a line segment, kids. Okay. Okay, you okay with the line segment that's formed there? Everybody with me? Okay, now listen carefully on this, because this is not easy. What's it say to do?
write equation.
Okay, this will be a tough one. If there's anything that's tough in here, it's this. Write an equation for my what?
I remember doing this. Oh my goodness.
Okay, when lines are perpendicular in coordinate planes, what's true of their slopes?
There.
Opposite, negative.
Opposite, reciprocal. Okay, so what we first of all want to find here, kids, when we do this is a volume. The first thing we want to do is always find the opposite reciprocal of your what?
So,
Okay. Okay, so let's do that first. Let's find the slope between these 2 points. So the slope here on the original segment is going to be y2 minus y1 over x2 minus x1. You should remember that. You've seen that a time or 10,000. Okay, what's my y2 value here, kids? 3 minus your y1 value. Right? 3 minus negative 1. You agree with the y2 minus y1 part?
Yeah.
What am I going to plug in for x2 minus x1? Negative 11 minus what?
5.
Okay, so let's simplify some stuff. So this is 4 up top. You all agree with that?
Yeah.
This is negative 16 on the bottom, which reduces to 1 over what? Okay, so it's really negative 1/4, right? Okay, so this is the original slope. So what's the opposite reciprocal for a slope?
4.
Okay, so the slope we need, I'm going to write this right down here. So slope we need, actually I'm going to write it this way. So upside down t means perpendicular. So perpendicular slope is what value again?
4.
Okay, so we know we're writing an equation that has a slope of 4. That's going to make my perpendicular. Now, this next thing I need to know is, well, if I'm going to be a perpendicular, which we've got the slope for, bisector, we've got to have the midpoint. Okay, so
Just guess.
step 2, you could almost guess on step 2. What if I told you in step 2 to find the midpoint in step 2? Kids, the midpoint is just simply the average of the x's and the average of the y's. Find the midpoint. In other words, x1 plus x2, cut that in half. Where's the middle of that? Comma y1 plus y2, cut that in half. So take a look up here. What are the x values again? 5 and what? 5 and negative 11. Add them up. Negative 6 cut in half now would be, so the midpoint is negative 3, comma, take negative 1 and 3 and add them up.
2.
2 cut in half would be what?
1.
Okay, here's the deal, kids. We need to pass through the midpoint, which is what? Negative 3, comma, 1. Here's the deal, kids. We have a slope that we know passing through a point that we want to go through. So boy, if I have point and slope, we could really use what form? Step 3, use point slope form. Anybody recall point slope form for an equation?
Y.
Who said sadly?
Wait, is it the y one? Y equals mx plus b?
Close, that's slope intercept form.
Point slope.
If I remember y minus,
Y minus b. Y minus. Oh my gosh.
Equals m x1.
I hate how I just forget things. Like I should know this.
point slope form, remember that?
Honestly.
That's point slope form that we're going to use, okay? So we're going to plug in what we know. What slope are we using, kids? 4. Through which point? Negative 3, comma what? Let's plug stuff in. What? You making fun of my socks?
Oh my gosh, that's enough. I took a time.
It's a face that you made about something.
Well, you're too stupid at it.
All right, you ready? Let's go. Here we go. Y minus, what's the y1 value? What is the y value and the point I want to pass through, kids? That's going to equal my slope. Do we know what slope I'm trying to have here? X minus the, when I go minus negative 3, this one becomes what, kids? Okay, let's simplify some stuff. This becomes y minus 1 on the left. Help me distribute on the right. What do you end up with for in slope intercept form then?
Plus 11.
4x plus. There it is, y equals 4x plus 13. You okay with that? Yeah. Okay, this should be the equation of a what?
Now that's why I understand.
What kind of bisector? Between these 2 points. Let's go back to decimals in our graph. Let's just see how good we were. There's the segment that was formed between the 2 points. What equation did we come up with?
Y equals 4x plus 13.
Does it look like it goes through the middle?
Yes, sir.
Does it look like there's a right angle formed up there? I'd say we're pretty spot on, wouldn't you guys? Questions at all?
It's okay.
Yeet.
Okay. So let me do this. That's it, isn't it? That was our last example, right?
Yeah.
Okay, let me